Let's start off this section by a quick overview of object relational mappers and the problem they try to solve. So you know that in relational databases, data is stored as rows in tables. So when pulling up data from a relational database, we need to map these rows into objects. In the past, we used to do this by hand, and this was pretty repetitive and time-consuming. So we would have to write a SQL query, send it to the database, read the result, and map it to a bunch of objects. So for each record, we will have to create a new object and set its attributes. This is where an object relational mapper comes into the picture. An object relational mapper, as the name implies, maps objects to relational records, and that frees us from writing a lot of repetitive code. So using an object relational mapper, we don't have to write SQL code to query or manipulate data. We can code in an object-oriented programming language like Python. The ORM will then translate our Python code into SQL code at runtime. So does it mean we never need to write SQL? No. When dealing with complex problems, ORMs can't produce efficient SQL queries. So that's when we need to jump in and write optimized SQL queries by hand. But overall, ORMs help us reduce complexity in our code, make it more understandable, and get more done in less time. A good example of that is Django migrations. Using these migrations, we generated our database tables almost instantly. We didn't have to write any SQL code or use a tool like DataGrip to create our tables, add relationships, indexes, and so on. Django migrations took care of all of that for us. So migrations are part of Django ORM. Also, all the model classes we have created so far inherit from the model class in Django. This model class is also part of Django ORM. So as you will see in this section, all our model classes inherit the functionality to query or manipulate data from the base model class. Now, once in a while, you see someone like our popular John Smith who hates ORMs and prefers to write every bit of code by hand because he believes ORMs are slow. What John is missing here is that he doesn't understand that the more code he writes, the more bugs he or someone else has to fix in the future. There is an old saying that says, the best code is no code. Writing and maintaining all that extra code costs time and money. Someone is paying for it, your employer or your client. If you were that person, you wouldn't want someone else wasting your money writing code that was unnecessary, right? Throughout my career, I've seen so many projects over-engineered by people like John that never made it into production. In my opinion, a good software engineer is one who delivers working software in time. Building the best, most optimized solution that will never make it to production is not something to be proud of. So use the right tool for the job. As I said, ORMs don't perform well when dealing with complex queries. But that doesn't mean we should never use ORMs. We can use them in a lot of cases, perhaps for the most part. Remember the old saying, premature optimization is the root of all evils. So don't optimize your code unless you have proof that it's slow. So that's it for the Django ORM. Let's move on to the next lesson.